Hello everyone, this is our 10th lecture of module 2 and today's topic is RAPS test. We already have learned all the tests for series and which are included in your syllabus up to Cauchy root test, and today's topic is RAPS test. RAPS test. First of all, let me tell you, we can apply RAPS test when D'Alembert ratio test fails. Okay, so note RAPS test is applied when D'Alembert ratio test fails. Clear? So first of all, we have to show that D'Alembert ratio test fails, then we can use RAPS test. Okay, so let's start. So first statement. So suppose we have a positive term series. So let summation un be a positive term series. Positive term series. Okay, and limit n tends to infinity n into un by un plus 1 minus 1. This is equals to L. Okay, limit n tends to infinity n into un by un plus 1 minus 1. This is equals to L. Now if L is greater than 1, then summation un is convergent. Okay, this is the result is opposite of D'Alembert ratio test. The D'Alembert ratio test was if L less than 1 then convergent, but in that case in RAPS test if L greater than 1 then convergent. Okay, second, if L less than 1 then summation un is divergent. Okay, and number 3, if L equals to 1 then test fails. Clear? So first of all we have to find out un, then un by un plus 1. No, actually first of all you have to find out un, then apply D'Alembert ratio test. If D'Alembert ratio test fails, then you can apply RAPS test. Okay, then find out the limit n tends to infinity n into un by un plus 1 minus 1. This is equals to L. Now if L is greater than 1 then this is convergent. If L is less than 1 then the series is divergent, and if L is equals to 1 then RAPS test fails. Clear? Okay, so let's solve a problem. Question: test the convergence of the series 1 plus 3 by 7 into x plus 3 into 6 divided by 7 into 10 into x square plus 3 into 6 into 9 divided by 7 into 10 into 13 into x cube plus dot dot dot, and also it is given that x is greater than 0. Okay, so this is the question. Here you can see that in this pattern the first number is not satisfying the pattern. Okay, here the power is x to the power 1, this is the power x square, this is the power x cube. If I include the first term, so here the power must be x to the power 0. But in my first lecture I have told you that the number starts from n equals to 1. Okay, so obviously we cannot take x to the power 0. Clear? That means this pattern, the first number, this is not satisfying the pattern of the series. So obviously we have to remove or we have to omit the first term. Clear? So let's write omitting the first term. Omitting the first term. Okay, so if I omit the first term, so obviously this term, now this is our first term for n equals to 1. Okay, so let's find out what is un. So omitting the first term, un equals to, okay, so this is x for n equals to 1, x, n equals to 2, x square, n equals to 3, x cube. That means for n equals to n, that will be x to the power n. Clear? Now when n equals to 1, here we have only one ratio, or you can say only one number. Here when n equals to 2, here we have two ratios, 3 by 7 and 6 by 10. For n equals to 3, we have three ratios, 3 by 7, 6 by 10, 9 by 13. Okay, so obviously when n equals to n, there will be total n ratios. Clear? Now first let's write the denominator, sorry, let's write the numerator. Let's write the numerator. First term, n equals to 1, 3, n equals to 2, 3 into 6. Okay, that means 3 square, no sorry, 3 into 2, 3 into 2, yes or no? First term is 3, we can write 3 into 1. Second term is 3 into 6, that means the first term into 3 into 2. Okay, and next term is 3 into 6 into 9, that means the first previous two numbers into 3 into 3. So obviously we can write the nth term will be 3, all the previous numbers, 3 into 6 into 9 dot dot dot, and the last number, last digit is multiplied by the n, so this will be 3n. Clear? Now you can verify. When u1 means n equals to 1, so that will be 3. Okay, just I am writing the numerator. When n equals to 2, that means u2, so first term into n equals to 2, so 3 into 2, 6. Yes, it is satisfied. Now u equals to 3, first two terms into 3 into 3, that means 9. Yes, it is satisfied. So the numerator is correct. Now let's find the denominator. First is 7 into 10, then 7 into 10 into 13. Okay, 7 into 10 into 13. Okay. So for n equals to 1, the number is 7. For n equals to 2, the number is 7 into the last digit. For n equals to 3, 7 into the last digit is, this is 10 na? 7 into 10, so this will be 10 into 7 into 10 and the last digit, and the last digit is 13. So let's try to find out the pattern. When n equals to 1, so this is of the form 7, we can write 7 in this form, 3 into 1 plus 4. 7 into 10, that means 7 into 3 into 2 plus 4. Yes or no? And this is 7 into 10, previous two terms, into 3 into 3 plus 4. Clear? That means when n equals to n, so multiply all the previous numbers, 7 into 10 into 13 into dot dot dot, and the last number will be 3n plus 4. Clear? Because you can see that for every value of n, the last number is of the form 3n plus 4. So this will be 7 into 10 into 13 into dot 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 3n plus 4. Clear? This is our un. Now let's find out un plus 1. Un plus 1 means next term. So this is equals to, okay, here you can see the difference between every term is 3 na? So after 3n, the next term will be 3n plus 3. So the numerator is 3 into 6 into 9 into dot 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 3 into 3n plus 3 divided by 7 into 10 into 13 into 3n plus 4 Again here the differences are 3. So 3n plus 7 plus 3. So this will be 3n plus 3n plus 4 plus 3. So this will be 3n plus 7. Okay, this is your un. Now this is multiplied by x to the power n. So obviously here the next number will be x to the power n plus 1. Okay, I think clear. So now let's find out D'Alembert ratio test. Limit n tends to infinity un plus 1 divided by un. So this is equals to limit n tends to infinity un plus 1 means 3 into 6 into 9 dot 3n into 3n plus 3 divided by 7 into 10 into 13 3n plus 4 3n plus 7. This is un plus 1 into divided by un. So this will be 7 into 10 into 13 3n plus 4 divided by 3 into 6 into 9 3n. Okay, into x to the power n plus 1 divided by x to the power n. So this is equals to, here you can see all the terms up to 3n are cancelled. Similarly all the terms up to 3n plus 4 are cancelled. Also here this is x to the power n plus 1, this is x to the power n, so you will get x. Okay, so what we are getting, limit n tends to infinity 3n plus 3 divided by 3n plus 7 into x. Okay, now divide by n. So this will be limit n tends to infinity 3 plus 3 by n divided by 3 plus 7 by n into x. So this is equals to limit n tends to infinity 3 by n is 0, 7 by n is 0. So you are getting 3 by 3 into x. That means this is equals to x. Clear? So the answer is x, but we don't know the value of x. X may be less than 1, may be greater than 1, may be equals to 1. Okay, so we have to write by D'Alembert ratio test, D'Alembert ratio test, if x is less than 1, summation un is convergent. Okay, if x greater than 1, summation un is divergent. Okay, and if x equals to 1, test fails. Clear? So actually we don't know the value of x, so we already have gotten that if x is less than 1, the series will be convergent, x greater than 1, the series will be divergent, but we don't know if x is equals to 1, the series will be convergent or divergent. We don't know means we are not getting any result from D'Alembert ratio test. So further we have to, actually we need to calculate the result. So we cannot use the D'Alembert ratio test for x equals to 1. Now we have to use Rabb's test, because for x equals to 1, D'Alembert ratio test fails. Okay, now we have to use Rabb's test. So for x equals to 1, so when x is equals to 1, so directly you can write actually. Okay, what will be un? This is our un, na? 3 into 6 into 9 up to and so on. Just you have to put x equals to 1. So this will be 3 into 6 into 9 3n divided by 7 into 10 into 13 up to 3n plus 4, and x equals to 1. So 1 to the power n will be 1. And similarly un plus 1, this is equals to 3 into 6 into 9 up to 3n into 3n plus 3 divided by 7 into 10 into 13 3n plus 4 into 3n plus 7. Clear? Now you have to use Rabb's test. So limit n tends to infinity n into un by un plus 1 minus 1. So this is equals to limit n tends to infinity n into, actually you need not to calculate un by un plus 1. Why? Because we already have calculated un plus 1 by un here. What is the result? This one, 3n plus 3 by 3n plus 7 into x. Yes or no? We already have calculated un plus 1 by un. This is the result. Now we need un by un plus 1. So this will be reversed, na? 3n plus 7 divided by 3n plus 3 and into 1 by x, but x is equals to 1. So the result is 3n plus 7 divided by 3n plus 3. Just put these values. Okay. So this is equals to, this will be n into 3n plus 7 divided by 3n plus 3, okay, minus 1. This is equals to limit n tends to infinity n into, so 3n plus 7 minus 3n minus 3 divided by 3n plus 3. So 3n cancelled, you are getting limit n tends to infinity n into, okay, so this is equals to 4. 7 minus 3, 4. 4 into n, 4n. So you are getting 4n divided by 3n plus 3. Okay. Now divide by n. So this will be limit n tends to infinity 4 by 3 plus 3 by n. Now limit n tends to infinity 3 by n will be 0 and the answer is 4 by 3. Now 4 by 3, this is obviously greater than 1. Okay. And by Rabb's test, when the limit is greater than 1, the series is convergent. So you can say by Rabb's test, the series is convergent when x is equals to 1. Clear? So finally summation un is convergent. We are getting convergence result in two cases, when x is equals to 1 and when this one, when x is less than 1. Yes or no? That means when x is less than equals to 1, the series is convergent. Yes or no? So we can write summation un is convergent if x is less than equals to 1 and divergent if x is greater than 1. This is the complete answer. Okay. I think it is very clear. So let's solve another problem. Next question. Discuss the convergent of the series half plus 1 into 3 divided by 2 into 4 plus 1 into 3 into 5 divided by 2 into 4 into 6 plus ... Solution. First un. Here un equals to, for n equals to 1, here we have only one term. N equals to 2, 2 terms. N equals to 3, 3 terms. So n equals to n, there will be n terms. Clear? Now first write the numerator. Numerator is 1, then 1 into 3, then 1 into 3 into 5. So un will be 1 into 3 into 5 into ... What will be the last digit? Last digit. Okay, so just we have to focus on the last digit. For n equals to 2, last digit is 3. N equals to 3, last digit is 5. Okay. That means if n equals to 2, last digit is 3, that means 2n minus 1, na? 3, 5, all these numbers are odd numbers. So if I write 2n minus 1, so for n equals to 2, so this will be 4 minus 1, that means 3. Yes, it is correct. Where n equals to 2, n equals to 3, so 2n minus 1, that means 3 into 2, 6, 6 minus 1, 5. Yes, it is correct. So this last digit will be 2n minus 1. Now let's write the denominator. 2 into 4, 2 into 4 into 6, all the even numbers. So the 2 into 4 into 6 up to last digit will be 2n. You can satisfy. Just we have to focus on the last digit. So if 2n, when n equals to 1, last digit 2, n equals to 2, last digit 4, n equals to 3, last digit 6. Clear? So this is our un. Now calculate un plus 1. So just next number, that means 1 into 3 into 5 dot 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 2n minus 1 into difference between every term is 2. So this will be 2n plus 1 divided by 2 into 4 into 6 dot 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 2n into plus 2, that means 2n plus 2. Okay, now apply D'Alembert ratio test. Limit n tends to infinity un plus 1 divided by un. This is equals to limit n tends to infinity. Okay, so 1 into 3 into 5 up to 2n minus 1 into 2n plus 1 divided by 2 into 4 into 6 up to 2n plus 2. 2 into 4 into 6 up to 2n divided by 1 into 3 into 5 up to 2n minus 1. So up to 2n all the numbers cancelled, up to 2n minus 1 all the numbers cancelled. So what we are getting, this is equals to limit n tends to infinity 2n plus 1 divided by 2n plus 2. Okay, now if I simplify this, if I divide by n, so limit n tends to infinity 2 plus 1 by n divided by 2 plus 2 by n. So 1 by n will be 0, 2 by n will be 0, answer is 2 by 2. So this is equals to 1. So in D'Alembert ratio test we are getting the limit 1, and we know when the limit is 1, D'Alembert ratio test fails. Okay, so D'Alembert ratio test fails. Clear? Now we have to use Raps test. So limit n tends to infinity n into un by un plus 1 minus 1. Okay, now let me tell you one thing. If D'Alembert ratio test fails, we can use Raps test. Also we can use comparison test. Okay, if D'Alembert ratio test fails, we can use Raps test. Also we can use comparison test. But when we have to use comparison and when Raps test, if you know what is un, if there is any degree difference between numerator and denominator, then use comparison test. And if there is no degree difference, then use Raps test. Okay, I am repeating. If D'Alembert ratio test fails, then you can use both Raps test and comparison test. But which one will be easier? If there is degree difference between numerator and denominator, you use comparison test, and if there is no degree difference, then use Raps test. Clear? So obviously here un, there is no degree difference, so obviously we have to use Raps test. So limit n tends to infinity n into, what is un by un plus 1? This is our un plus 1 by un. So reverse of this, so 2n plus 2 divided by 2n plus 1, okay, minus 1. This is equals to limit n tends to infinity n into 2n plus 2 minus 2n minus 1 divided by 2n plus 1. 2n cancelled. So you are getting limit n tends to infinity 2 minus 1 1. So this will be n by 2n plus 1. If I divide by n, so limit n tends to infinity 1 by 2 plus 1 by n. So the 1 by n is 0. You are getting answer half. And half is less than 1. Yes or no? Half is less than 1. And by Rabb's test, the series is divergent. Clear? I think Rabb's test is very clear. I am just again I am repeating the main points of Rabb's test. First of all, you can use Rabb's test when D'Alembert ratio test fails. Okay. Second point is actually you can apply both comparison test and Rabb's test. If there is a degree difference between numerator and denominator, use comparison test. Comparison test will be easier. And if there is no degree difference, use Rabb's test. Okay. If in question paper it is mentioned that solve by Rabb's test, then obviously you have to use Rabb's test. There you cannot use comparison test. Clear? If the mentioned method is mentioned, so obviously you have to use the mentioned method. And if the method is not mentioned, then you can choose any one between comparison and Rabb's test. Just you have to see that if there is any degree difference, then comparison. No degree difference, Rabb's test. Clear? Okay. Thank you so much.